All right, welcome back. So we are continuing with our sections here concerning logarithms. This is section 7.4. This is where we start getting into the properties and applications of logarithms. So the first thing we're going to cover here are the three properties of logarithms. Okay. So our first property here is the product property, which is labeled in green here. And so this one states if we have, sorry, I had to turn on my pen there. If we have a log of any base, okay, I just happen to put a there because that could mean any base, could be log base 2, log base 5, whatever, okay. So log base a of x times y, okay, so whenever you see multiplication like that, we can actually separate this. We can separate that multiplication with addition, okay. Now notice, I have to write my log twice, okay? So, whenever I see multiplication, one more time, whenever I see multiplication, x times y, I can split it into 2 here, okay? And vice versa. We're going to see that here in a minute, that if we see addition of 2 logs, we can turn them into a multiplication problem as well. All right, let's look at a couple of examples before we go on to our second property here, okay? All right, so if we have log base 5 of a times b, okay, this is going to equal log base 5 of a plus log base 5 of b, okay. Very important that, of course, that you write the log there twice, okay, when you're expanding it, what we call expansion, okay. All right, so this is an example of expand. Okay. You're going to see 2 types of problems in this lesson. It's going to be expand or condense. All right, so my second example here, I'm going to show condensing. All right, so if we have log base 2 of x plus log base 2 of m, this is going to equal log base 2 of x m. Okay, so we're just going to put them both together. Okay, so this is considered a condensed problem. Now, there's not going to be very many problems in HOX where it's just one property. Most of the problems in HOX are going to concern multiple properties, okay? And again, we'll see some of those here in just a minute, okay? So these are just basic examples just showing one property, expanding and condensing. All right, let me move back up here. So when we see product property, product means to add. Or if you see addition, we can turn it back to a multiplication problem, okay? Depending upon if I'm expanding or condensing. All right, let's look at our second property. This is the quotient property. So if I see division this time, like for example, log of a of x divided by y, okay? If I see division, that means to subtract my logs. So log a of x minus log a of y. Now, order is important there. Make sure it's numerator minus the denominator, okay? Very important. All right, so I see division here. I'm going to split it. So I have to write log twice. And that's going to be not addition, but subtraction this time, okay? So product means to add, quotient means to subtract. All right, let's look at an example of each. All right, so if I have log base b of 3 over x, this is going to equal log base b of 3 minus log base b of x. Okay. Again, this is an example of expanding. Okay, when I expand, I'm going to have to write my log more than once. When I condense, I only want to write my log one time. All right, so let's do an example of condensing using the quotient property. So if we have log base 2 of a minus log base 2 of b, this is going to equal log base 2 of A over B. All right? And again, this is an example of condensing. Okay? We're going from that long statement involving subtraction, and we're changing it into one simple statement using log once with A over B. All right, one more property you're going to have to be aware of is what we call the power property. Sometimes this is also called the exponent property. All right, so please be aware that it can be called two things. It can be called the power property or the exponent property. Now this one involves my exponent. So if I have log of like base A, and then we have a number taken to like the R power, this states that I can move that exponent to the front. So R times log base A of X. All right, so you can see that the exponent was moved from here to the front. All right, so and that can happen anytime. So if that had been X squared, I can move 2 to the front of that log. All right, let's look at a couple of examples there. We're going to look at expand and condense. All right, so expanding log base 5 of X cubed equals 3 times log base 5 of X. All right, this would be considered expanding. Now this one looks a little bit different than the expanding to the left because we actually had to write log more than once. Now there's no need to write the log more than once because all we're doing is moving that exponent that was here to here. So we're not adding any operation. We're not adding a addition sign or subtraction sign, so no need to write the log more than once. Okay, but that is considered expanding. All right, condensing would be the reverse of that. So for example, if I have 4 times log base 2 of A is going to equal log base 2 of A to the 4th power. This is considered condensing. All right, that 4 again being moved right there to the exponent for the letter A there. All right, so those are our 3 properties. Now, based on those 3 properties, let's work some examples here. Okay? All right, so you're going to see a lot of examples in here where it says to use the properties to expand or condense. Okay, so I have a couple problems here for expanding, and then we'll get into a couple of problems with condensing as well. All right, so the first thing and the best thing that you can do is always refer back to your properties itself, so that way you can determine which ones I need to use. All right, so we're going to expand here, which means I'm going to have to write this log base 6 probably multiple times. Okay? So first thing I have to identify, what is that? Well, that's 36 times x to the 8th. So that's product right there. I also happen to have an exponent there, which means that points to another one of my properties. That's the power property. Okay, so we have the product property and the power property. Okay, let's use the product property first. All right, so we're going to expand this out to say log base 6 of 36 plus log base 6 of x to the 8th power. Okay, so right there I just used the product property to separate that multiplication. Okay, to separate that 36 times x to the 8th. To separate that, I used the product property and put addition right in between there. Now notice I did have to write log base 6 twice. All right, now the next step would be to use the power property to move this exponent right here that I'm highlighting in yellow, to move that to the front. All right, so over here on the left side, this is going to stay exactly the same. Log base 6 of 36 plus 8 times log base 6 of x. Okay, and this is my power property. Okay, we move that 8 right there to the front. Okay, all right, now we are not quite finished yet. We have one more step to do. and that would be right here, okay? And we can actually physically solve that one, okay? So if you see a base is a number and my answer is a number, okay, because that's a base of 6 and my answer is 36, 6 to the what power is 36? Now this points back to section 7.3, so hopefully you're comfortable with section 7.3 at this point, okay? 6 to the what power is 36? That would be 2. 6 to the second power is 36. So this right here equals 2. So that's 2 plus 8 times log base 6 of x, and that is my answer. So there are quite a few steps on these particular problems, okay? All right, Hawk's example number 2. Use the properties of logarithms to expand the following expression as much as possible, okay? So the first thing that you see on here is probably, it's a fraction, okay? But don't worry about that. It's a fraction for now. Fractions just mean division, so that means that points back to one of our properties, and that's the property, that's the quotient property, okay? So let's go ahead and use the quotient property first. So we're going to do ln of 12 times x to the 9th power minus ln y to the 6th power, okay? And I'm just going to write over there on the side quotient because that's the property I just used. So that way we get rid of that that division statement there, that fraction that you see there, okay? Now, we still can't expand this further, okay? We see right here, just like we did in Hawk's example 1, that's 12 times x to the 9th, okay? So I can use the product property to expand that even further. All right, so ln 12 plus ln x to the 9th minus ln times y to the 6th. Okay, and that was our product property to separate that. All right. Now, hopefully you can see that and see that we still have one more property to do. If we have any kind of exponents there, that points back to my power property, which means I need to move those back to the front of those ln statements. All right, so ln 12 is going to stay exactly the same. ln 12 plus 9 times ln x. Now, there's really no need to put those parentheses, but I went ahead and left them. Minus 6 times ln y. Okay, and that was our power property. Now, a lot of students will sit there and ask me, why are we not simplifying that? Okay, because we simplified it earlier. Back up on Hawk's example 1, we did log 6 of 36 equals 2. Okay, now notice it says in the question, it says can be evaluated without a calculator. So can we do ln 12 without a calculator? That's the question. And the answer is no. Okay? Log 6 of 36, on the other hand, that was a little bit easier because 6 to the 2nd power is 36, so we know that equals 2. But in this case, this would be e to what power equals 12. And you can't solve that mentally. All right, so that means we are left with this as our answer. Okay? When you expand these, please make sure do not leave any exponents on those variables. Okay? Make sure you use the power property to move those to the front of the ln or log. All right, Hawk's example number 3. Use the properties of logarithms to expand the following expression as much as possible. Simplify any numerical expressions that can be evaluated without a calculator. Okay, now, we do see 12 times x here and we see 8 times y here, but this guy right here is a little bit of a problem. Okay, that addition statement in there. All right, we are expanding here. Remember, we are expanding here, okay? So this addition statement is a little bit of a problem. It kind of throws us off here a little bit, okay? So what we need to do is we need to find a GCF. So find a GCF, okay? GCF standing for greatest common factor. So we see there's a single x and a single y, so there's no GCF for the variables, but the 8 and the 12, my GCF looks like it would be 4. All right, so let's factor out a 4. So we have log base 4 of 4 times what gives me 12x, that would be 3x, plus 4 times what gives me 8y, that would be 2y. All right, let me make sure I put a note over here. Factor out the GCF. Once it's found, make sure you factor out the GCF, okay? And that's exactly what we did. We factored out that 4. Now, with this showing multiplication, because that's 4 times 3x and 4 times 2y, okay, if we were to distribute that back in there, we'd get exactly what my original statement looked like, okay? This is multiplication. And since this is multiplication, now I can use the product property to expand this out, okay? All right, so we have log base 4 of 4 plus log base 4 of 3x plus 2y. All right, now I have to look at this carefully to make sure that if there's anything else that I can simplify here. And I want you to look closely at this down here at the front. Can I evaluate that without a calculator? Can I solve that mentally? The answer should be yes. 4 to the what power is 4? 4 to the what power is 4? That would be 4 to the first power would be 4. Okay, so this equals 1. So 1 plus log base 4 of 3x plus 2y. And that is my answer for Hawk's example number 3. All right, I'm going to pause it right there and start a part 2.